Okay, we're going to look at putting everything together using completing the square, standard form, discriminant, x-intercepts, finding x-intercepts from vertex form, etc. So I'm going to do two examples, one in standard form, one completing the square, and then a working backwards, given points, find the parabola. Okay, so the first problem we're going to look at is y equals 1/2 x squared minus 2x minus 3. It's in standard form, ax squared plus bx plus c. So in this case, a is 1/2, b is -2, and c is -3. X coordinate is going to be the opposite of b over 2a. So the opposite of -2 is +2 over 2 times 1/2. Well, that's nice because 2 times 1/2 is 1. So 2 divided by 1 is 2. Notice that's also your axis of symmetry. The axis of symmetry always cuts through the x-coordinate of the vertex. So my axis of symmetry, don't forget your notation. It's important. You don't want to lose points for careless mistakes like that. All right, let's find y by plugging in 2. So y is 1/2, 2 squared, minus 2 times 2 minus 3. Order of operations, square the 2 first. That's 1/2 times 4 minus 4 minus 3. That's 2 minus 4 minus 3, which is -2 minus -5. So my vertex is at 2, -5. Okay. A is 1/2, so that tells me that it's positive. So it's a wider parabola. A is less than 1. Well, the opposite value of A is less than 1. So this is wide. Y-intercept, remember the y-intercept is always 0c. Make x 0 your whole math life. If you want to find the y-intercept, you make x 0. So in this case, the y-intercept is 0, -3. Okay, let's find some x-intercepts while we're here. So factoring with a fraction is kind of eh. So let's do the discriminant to even see if this has any x-intercepts, or just a little sketch here, a poor sketch. If the vertex is at 2, -5, right, whatever, that's in the fourth quadrant, and the y-intercept is at 0, -3, its potential, you got to be careful, like where is it exactly, the vertex compared to the y-intercept? So let's find the x-intercepts to get a much clearer picture of this. Don't want to factor with a fraction, so I'm going to use the discriminant. Okay, so b is -2. So why am I using this discriminant? Because I want to figure out, does this parabola have x-intercepts? And if so, how many? And then let's see, a is 1/2 and c is -3. So that's 4 plus 6, I believe, which is 10. Okay, well, 10 is greater than 0. So this has 2 x-intercepts. Okay, and then remember, this right here means therefore. Okay, let's try and sketch a graph. Oh, sorry, nope, let's finish finding the x-intercepts first. Well, you just did b squared minus 4ac. You figured out it was 10, so you've already got most of the quadratic formula done. So the opposite of b is +2, plus or minus the square root of b squared minus 4ac. Well, you just did that. B squared minus 4ac is 10. All over 2a, well, 2 times 1/2 is 1, so my x-intercepts are at 2 plus or minus root 10, comma 0. Those are the exact x-intercepts. Where are they? I have no idea. The square root of 10 is, I don't know, 3-ish. So my x-intercepts are going to be at 2 plus or minus 3. which is about 5 and about -1. All right, well, let's throw this whole thing together. There we go. I'm going to start with my vertex. So my vertex is at 2, -5. My axis of symmetry is at 2. My y-intercept, we said, was at 0, -3. My reflected point, take the y-intercept, reflect it across the axis of symmetry. Reflected point, symmetric point, whatever, same thing. And then we said the x-intercepts were around -1 and 5. Well, if you look at your parabola, right, it's around -1, okay, there-ish, and it's around 5 here. Yeah, that makes sense. My parabola could kind of sort of look like that. And there you have it. Okay, great. Let's look at a parabola that's in standard form that I want you to convert it to vertex form by completing the square. All right, so number 2. Y is equal to -x² plus 4x minus 3. Okay, and the directions here are going to be to complete the square. So even if you don't know how to complete the square, hopefully you're able to find the y-intercept. Y-intercept make x 0. So if all else fails, hopefully you can find the y-intercept. Okay, a must be 1. But a is not 1, a is -1. So I'm going to add 3 to both sides. And you have to factor out the negative sign. So it becomes x² minus 4x. Be very careful with that. -1 is not the same thing as +1. Complete the square, take half of b and square it, which I believe is 4. Keep the equation balanced. You did not add 4 to the right. When you distribute, that's -4. So you actually subtracted 4. You did not add 4. Y minus 1 equals negative. Factor it, it becomes x minus 2 squared. So from here to here, we factored. Remember, it's known as a perfect square trinomial. Okay, so it's almost in vertex form. So your vertex is at 2, 1, right 2, up 1. Your axis of symmetry is at x equals 2. We already found our y-intercept earlier. That's 0, -3. This parabola opens upside down because a is negative. Now I need to figure out those x-intercepts. Okay, I'm going to find the x-intercepts straight from vertex form. So this is not something that we have done in class, and it is something that I want to review with you that you may or may not remember from last year. So we're in vertex form. And we have y equals -x minus 2 squared plus 1. How do you find the y-intercept? You make x 0. So that gives me, sorry, I want to find the x-intercepts, my mistake. I want to find the x-intercepts. To find the x-intercepts, I'm going to make y 0. So you get 0 equals negative parentheses x minus 2 squared plus 1. Do not square root it yet. You have to isolate the squared quantity. So the first thing you need to do is subtract 1. Negative 1 equals negative x minus 2 squared. Cannot distribute. If this is the same thing as saying negative 1 quantity x minus 2 squared, so I'm going to divide by negative 1, and you get 1 equals x minus 2 squared. Now I can square root both sides. And don't forget plus or minus. So plus or minus 1 equals x minus 2. Add 2 to both sides. So this becomes 2 plus or minus 1 equals x. So this has nice perfect x-intercepts. 2 plus 1 is 3, and 2 minus 1 is 1. So we've got our vertex at 2, 1. We have our axis of symmetry. We have our x-intercepts. And try and squeeze a graph on here. We'll see how I do. Okay, so let's see. Vertex is at 2, 1. Axis of symmetry. Remember, A is negative, so it opens upside down. 3, 0, 1, 0. And then we said the y-intercept was negative 3. 1, 2, 3. Reflect it over. And there's my very poorly drawn graph. Okay, let's review the discriminant. And then we're going to talk about working backwards and finding an equation given points. So the discriminant. B squared minus 4ac greater than 0, 2 x-intercepts. Equal to 0, 1 x-intercept, which is the same as the vertex. It means the vertex is on the x-axis. And then b squared minus 4ac less than 0. This is no x-intercepts, 2 imaginary. Okay. So the last thing we're going to do is, if you know points on the parabola, how can you write its equation? Okay, so I'm going to give you that the vertex of some parabola is at, how about, I don't know, negative 3, 2. Okay, well, vertex, if I know the vertex, I'm going to write it in vertex form. I'm going to use HK, and I'm going to have y equals, let's review that. The vertex form, A, quantity x minus h squared plus k. So A, which I don't know, you cannot assume it's 1. You cannot assume it's 1. X minus h, so in that case this becomes plus 3 squared plus k. You'll also see vertex form. Every book is different. You'll sometimes see it written as y minus k equals a x minus h squared. And by the way, that looks just like point slope form. This looks just like point slope form. Point slope form, y minus y1. Instead of a, we say m, x minus x1. These are almost the same. K, y1, a point on the graph. H, x1, a point on the graph. And a and m. Okay, so this is what I know so far, but this doesn't really tell me much. I have to figure out what A is. A, does the parabola open right side up or upside down? Is it wide or is it narrow? So I'm also going to tell you that it goes through the point one, 7. Well, I gave you an x and a y. Let's plug into our vertex form. So we have y right here. Y is 7. I don't know a, but I'm going to figure a out. You can't assume it's 1. X, which is 1, plus 3 squared plus 2. Oh, I can solve for a now. This is 7 equals a times 4 squared plus 2. It's going to be kind of nasty, but it works. Subtract 2, you get 5. 4 squared, 16. Divide by 16. A is 5/16. So the equation of this parabola with a vertex at -3, 2 that goes through the point 1, 7 is y equals 5/16 x plus 3 squared plus 2. Okay. So things to know. How to write an equation, which is what I just did in this example right here. The discriminant. Completing the square and finding all of the information. And then the first problem I did was a problem in standard form and finding all of the information. So you have a quiz next week. And the quiz next week, knowing how to complete the square. Knowing how to find the vertex from standard form. Which is the opposite of b over 2a, the f of the opposite of b over 2a. Understanding how to find the discriminant. B squared minus 4ac. And what the value of the discriminant tells you. How to write an equation from how to write the equation of the graph given points. Given the vertex and a point. By the way, you have to be given the vertex. You cannot find the equation of a parabola from 2 random points. One of the points has to be the vertex. What else is on the quiz? Oh, factoring. So that blue worksheet. So let's see. So the quiz for you guys is going to be Wednesday. Okay. That is putting it all together. And of course, save the video so that you can watch it and use it as a study guide.